You know that humble streetlight you walk under every single night? Well, it's going through its biggest, most profound transformation in over 100 years. Seriously. There's a revolution happening literally right above our heads, and it's all about moving from, old school brute force physics to sleek digital intelligence. So, let's get right into it. All right, so for decades, the world ran on something called high-intensity discharge technology. You'll hear me call it HID. This stuff basically owned the night. It started back in the 30s with these kind of bluish-white mercury vapor lamps, then came the more advanced metal halide, and of course, who could forget that iconic orange glow of high-pressure sodium lamps? I mean, you've seen them everywhere. For its time, this was powerful, long-lasting stuff, the undisputed king of lighting up our cities. But its whole way of working was, well, about to become a thing of the past. Okay, check this out. I want you to remember this number, over 150 lumens per watt. So what on earth does that mean? Well, that's the luminous efficacy of a modern LED. The easiest way to think about it is like MPG for a light bulb. It's all about how much light you get for every watt of electricity you put in. And here's the kicker. A lot of those old HID lights, they struggle to get much past half that. So we're not talking about a small little improvement here. This is a massive, game-changing leap in efficiency. And that's why this is so important to understand. The move from those old HID lamps to modern LEDs, it's not just about swapping out one bulb for another. This isn't like changing a light bulb in your lamp at home. No way. We're talking about a fundamental shift in the actual physics, in our ability to control the light and what that light can do. It is a complete reinvention of how we see our world after dark. Okay, so to really grasp just how revolutionary this LED tech is, we first have to take a look back at the old way of doing things. We need to understand what we were dealing with before. Because for decades, lighting up our cities meant trying to tame this really violent and kind of inefficient process that was happening inside every single one of those old streetlights. At the very heart of an old HID lamp is something called a plasma arc. And what is that? Essentially, it's a continuous, contained bolt of lightning. I'm not even kidding. You've got this device called a ballast that zaps a super high voltage arc through a sealed tube. That tube is filled with pressurized gas and some metal salts. The arc heats everything up until it vaporizes and starts to glow like crazy. It is a total brute force way to make light. And, as you're about to see, it comes with a lot of problems. And this whole process, it is incredibly slow. I mean, we're also spoiled now by instant-on lights, right? You flip a switch, bam, light. Not with these. An HID lamp has this whole multi-stage warm-up. We're talking 5, sometimes even 15 minutes to get to full brightness. I definitely remember being a kid and watching the streetlights flicker on one by one. It felt like it took forever. And forget about it if the power went out. You'd be stuck in the dark all over again because they had to cool all the way down before they could even start that slow restart process. Now this visualizes one of the core flaws perfectly. So because these lamps run on AC power, the electricity is constantly reversing direction, right? Dozens of times every second. Well, every single time that current reverses, that plasma arc, that little bolt of lightning, it actually goes out for a split second, and it has to be violently zapped back to life with a huge spike in voltage. You can see that spike right there. That's the reignition peak. Think about it like this. It's like a boxer getting knocked down and having to struggle back to his feet 120 times every single second. It puts an unbelievable amount of stress on everything inside that lamp, which leads to waste, inefficiency, and eventually failure. And of course, that constant, violent process really takes its toll. That endless cycle of zapping the arc back to life, it literally blasts tiny particles of material off the electrodes inside the lamp. And where does that material go? Well, it gets baked onto the inside of the glass tube. That's the blackening you can see in this picture. This is called lumen depreciation, and it means the lamp just gets dimmer and dimmer and dimmer over its life. The color also starts to shift, getting all weird and inconsistent long before the lamp actually burns out for good. But then, everything changed. Along came the solid-state revolution, a fundamentally better, smarter way to make light. We're talking about the arrival of the light-emitting diode, the LED. And this wasn't just a minor upgrade, it was a total reinvention. It makes light using a process that is so much more elegant and so much more controlled than that plasma arc we just talked about. I mean, just look at this comparison. When you put them side by side, it's not even a contest. Instead of that chaotic plasma arc, an LED uses a super stable semiconductor chip. We already talked about efficacy. You're getting more than double the efficiency. The lifetime?
We measure it in something called L70, which is just how long it takes to fade to 70% of its original brightness. We're talking 50, even 100,000 hours versus maybe 20,000 for an old HID. They're instant on, you can dim them perfectly, and when they do fail, it's a slow, graceful, predictable fade, not a sudden poof and you're in the dark. It is an absolute knockout on every single metric.
And get this, it's not even just about how efficiently they make light, it's about where that light goes. Think of it this way. An old HID lamp is like a shotgun. It just blasts light out in all directions, up, down, sideways. Then you need these big, clumsy reflectors to try and bounce it down to the ground. You end up wasting a ton of it as glare and light pollution. But an LED is like a sniper rifle. It's a tiny directional source of light to begin with, and you can pair it with these amazing, tiny, precision-engineered lenses to put a beam of light exactly where you need it, and nowhere else. But here's where things get really, really interesting. What if I told you the most revolutionary part about LEDs isn't even the light itself? The real game changer, the thing that blows everything else out of the water, is the fact that LEDs are semiconductors. They're tiny little electronic devices. And that means you can connect them to a network, you can make them intelligent, in a way that was just completely impossible with a dumb tube full of hot gas. I mean, look at how fast the control technology has evolved. In the past, you had a mechanical time clock or a simple photocell. The light was either on or it was off. That's it. Then we got digital protocols like Dolly, which was a huge step because now we could dim the lights. But the future, where we're at right now, is a standard called D4i. This basically gives every single light fixture its own onboard computer and data connection. It's like an IP address for every streetlight, creating a massive internet of lights. So what does that actually mean? What makes a light smart? Well, it means it can have its own sensors on board, for motion, for ambient light, you name it. It can communicate wirelessly over a network. It can report back in real time exactly how much energy it's using, and maybe the coolest part, it can run diagnostics on itself and report any problems with its internal driver. This allows a city to connect everything to a central management system. They can create adaptive schedules, dimming the lights late at night when no one's around to save tons of energy. This isn't science fiction. It is a total game changer for how cities are run. And this constant stream of data unlocks something huge: predictive maintenance. Think about it. The old way was waiting for someone to call and complain, "Hey, the streetlight on my corner is out." Now, the system gets an automatic alert directly from the light fixture itself. The light can say, "Hey, my internal temperature is too high," or "My performance is degrading." This means you can send a crew to fix the problem before it even happens. It's about being proactive, not reactive. Okay, so we've talked about saving energy and making maintenance smarter, but the benefits of this revolution go way, way beyond that. For the very first time, this new technology gives us the tools to fight back against one of the most widespread yet overlooked forms of environmental damage: light pollution. There are amazing groups out there, like Dark Sky International, who have been sounding the alarm on this for years. Because light pollution, it's not just about not being able to see the stars. That's a tragedy, for sure. But wasted light at night actively disrupts ecosystems. It harms wildlife, and it can even impact our own health. Restoring the natural nighttime environment isn't just a nice idea, it's a critical environmental goal. So how exactly do smart LEDs help protect the night? Well, it comes down to a few key things. First, shielding. Remember those precision lenses? They aim all the light down onto the street and sidewalk, eliminating that wasteful sky glow that washes out the stars. Second, we can control the light's color spectrum. We can specify warmer color temperatures under 3000 Kelvin, which dramatically reduces the amount of harmful blue light that messes with wildlife. And finally, adaptive dimming. Those smart controls let us dim the lights late at night, or even turn them off, giving the darkness back when we don't need the light. And all of this leaves us with a really fascinating and kind of profound question. For pretty much all of human history, we've struggled to push back the darkness. But now, for the first time, our technology, our ability to create light, has actually outpaced our need for it. We have the tools right now to create cities that are perfectly safe and beautifully lit, while also restoring the natural darkness of the night sky. So the question is, as our technology gets brighter and brighter, can we finally make the choice to make our nights darker